Number 18 might be the kind of question that you decide to skip if you're running short on time. We're near the end of the section. We can tell that it's going to be long and probably annoying. So it's okay to start making those kinds of decisions and using your time where you think you're going to get the most points. So if you're intimidated by this, I understand. That's okay. Try numbers 19 and 20. But it's not that bad. We just need to kind of sort through the information, and the best way to do that is to just show your work. So in this case, that's not even going to mean like math. We're going to start, the work that's most important here is going to be just taking the stuff from these sentences and expressing it in a way that's much more understandable. So let's just go sentence by sentence here. Students in a science lab are working in groups to build both a small and a large electrical circuit. Great. A large circuit uses 4 resistors and 2 capacitors. Okay, let's take that information and take it out of here. So L, a large resistor or a large circuit is 4 resistors and 2 capacitors. Okay, great. And a small circuit uses 3 resistors and 1 capacitor. So small is 3 resistors and 1 capacitor. So I know it looks like an equation, but it's really not. It's more just that I'm like simplifying and summarizing my information. If anything, this is maybe more like what we would do in the reading section to come up with a dumb summary. Just a better way of understanding what we're given. Let's keep going. We've done this, we've done this. Okay. There are 100 resistors and 70 capacitors available. And each group must have enough resistors and capacitors to make 1 large and 1 small circuit. What is the maximum number of groups that could work on this lab project? Okay, so we're going to have to divide out these 100 resistors and 70 capacitors to see how many possible groups we can fit or we can get with those 170. So what we need to do first is understand, okay, we've got 1 large circuit, a small circuit, but each group needs to make 1 of each, right? So we got to kind of add these 2 things up and see what we get. So in total, we're going to need, each group is going to need 7 resistors and 3 capacitors. Okay, so I don't know what the limiting factor here is going to be, so I need to do the division to kind of figure that out. So let's first focus on the 70 capacitors, and that means that we need to say, okay, each group is going to have 3, so how many groups would we be able to get out of those 70? So that's just a division problem. 70 divided by 3, maybe we need to do a little long division here. 3 goes into 7 2 times with 1 left over, so 3 goes into 10 3 times. We're going to have some decimals here, so that would be remainder 1. So okay, basically we can get 23 full groups worth of, what are these, capacitors? See, I don't even remember the story. That's how irrelevant it is to what's going on. Okay, so that might be an answer, because that's the division, but I need to check the other piece and see, because the resistors are in a different proportion. So I need to see which proportion is going to be the limiting proportion. So it's same process, 100, now we're dividing it by 7. 7 goes into 10 once, there's 3 left over, 7 goes into 30 4 times 28, and then there's 2 left over. And so there we go. We have a different value, and it looks like these resistors are going to be the limiting factor. So my answer is actually going to be the 14 that I just got here. And just to be clear, what does that mean? That means that I have 100 resistors in like a bucket, I guess. I don't know. And we're taking them out. We're giving 7 resistors to each group. And we can do that 14 times before we're basically out of resistors. Not totally out, but there's 2 left in the box. But as far as making more groups goes, 14 is the max. We do not have enough for a 15th group. So it's annoying, this question. There's a lot of stuff to kind of, sort through. But if we look back on what we did here and we showed our work, what was the result? Well, all the work really involved, addition and division. 2 very basic mathematical procedures. So a lot of times when the SAT is giving you a complicated story, they're not giving you complicated math to go with it. So that can kind of reassure you, if you're feeling nervous, that once you sort through the story, the rest should be pretty easy. And, I think that is the case here. Just make sure you've got enough time to sort through that story and get those points.